Okay, so first things we need to do, make sure you guys have your Ohm's law triangle here. All right, and the rules for our ohms are series circuits, where the total voltage is equal to the sum of the voltage drops. So V1, V2, however many there are. 15, there would be V sub 15. Total current is going to be equal to the current going through the first resistor, or second, or third, however many there are. And the total resistance, or sometimes written as REQ for equivalent resistance. They're the same thing. You just add all the resistors together, however many there are. Okay, you need to know that, current's the same at every single spot. The voltage is whatever the battery is going to be, and the voltage drops. So V1, V2 plus, or however many there are, has to add up and equal that number. No more, no less. And that to calculate total resistance, you add them Johns together. When you see this symbol, all right, you see how it's like a line with a circle. It's got a number and a unit here. And see how it goes over the battery? That means that's telling you what the battery's voltage drop would be. So that's the value of the battery. So that would be like the same as just basically seeing this here and 90 volts was there. It's the same exact thing. All right. So how many resistors do we have? We have 2. So what we're going to want to do, all right, just the easiest way to get all the information that we need is V, I, R. You're going to make yourself a small little table. How many resistors are there? There are 2. So you're going to have 1, 2, and then if there's 3, you would write 3, 4, 4, but there's only 2, and then after that is a total column. Put in all the information that we know. Okay, we know what the total voltage is because that's the battery, so we have 90. The resistor value for 1 is 10 ohms. The resistor value for 2 is 20. That is all the information that is given, correct?
Do we have to draw a symbol? That's like a very stupid question.
No, not right now. Okay. So those are all the numbers that were given. Now it asks specifically for the total resistance, the total current, current in 1, current in 2, voltage 1, voltage 2. Okay, so if you do the table, everything becomes wicked easy anyway. So you can, even if they're only asking you for sure one specific thing, doing the table will give you everything that you need. Plus, I think it's just the easiest way. You're given all the resistor values. What do you do then? To find the total, add them. What's 10 plus 20?
30.
Okay, so now if you needed to draw the unit, okay, it's kind of just like an upside down little horseshoe thing for ohm. Okay, it doesn't really, it's whatever. It's like a little upside down horseshoe thing, volts, cool. So in order to get a missing spot in here, you need to have 2 of the 3 values. So the only one that we have that for right now is the total column, or the total row. See that? Now that's where Ohm's law's triangle comes in. So if I want IT, all the subscripts have to go together. So the T's all go together, the 2's and the 1's. So IT would equal, go to the triangle, V is above, and R is on bottom, but we need the totals. So now we can substitute in our numbers. So we're going to do, what's our total voltage? 90. And the total resistance that we have is 30. 90 divided by 30 is 3. And the unit for current is amps. So now that you have this dude, now we can drop it out. Drop it in here. Not 30, but 3. One of the rules for series circuits is current is the same everywhere. So once I get it at any one position, I can fill in that whole column. Dope. Dope. So now you see how V1 and V2 are still blank, but look, we have 2 of the 3 spots. So now then you go to Ohm's law's triangle. So I want V, right? If I covered up V, I times R. But again, you have to go with the specific subscripts. So V sub 1 would equal I1 times R1. Okay, what is my I1? So I go to I1, and that's 3. And R1 was 10. 3 times 10 is 30 volts. Before I write that in, I'm going to just make a small little...
Is that only going to be 60?
It will come out to be 60.
Is that like a coincidence that, or no? Like that goes 30, 60, 90,
You could say you could say it's a coincidence. But before I write those in as my final answers, this is just one piece I want to say. So we're going to do V2, which is I2 times R2. All right, current 3, resistance 20, 3 times 20 is 60 volts. After you calculate all your voltage drops, this is what you need to do, because, all right, like paying a toll, essentially you're basically going to run out of all your voltage. Okay, you can't have any more or any less. So you have to basically use up all 90 going through all your resistors. If for some reason they came out with like a decimal, let's say this was like 30.7 and this was, I don't know, 59.4. Okay, what you'd always want to do and double check is once you get your voltage drop values, add them up. This case over here comes out to be 90. And if it does, perfect, then you use those values. But this one, if you added them together, this comes out to be like 90.1. In which case, one of these would have to be rounded differently. One of them would have to be rounded differently in order for it to work. Okay, so that's why I always say add the voltage drops first to make sure that they equal your total voltage. If they do, then you're all good. All right, then you're all good. So we have our 30 and our 60. And what did they want? They wanted RT, which we have as 30. I's are all 3. V1 was 30, V2 was 60. Boom. Now, again, let me explain a couple other pieces. For example, in this drawing here, in this circuit diagram, you guys see this symbol with the circle in A. That is an ammeter which reads the current. So that is, for this one, that would be I1, I2, and IT. You're given them. Here's the total voltage, and then they give you a voltage drop. So if you draw out the table like you're shown, you put in the pieces that you are given first, then from there you should be able to figure out the missing pieces using Ohm's law or an addition subtraction. So if you know that 75 is the total and the current is 5, 75 divided by 5, what the heck is that? 15? See you guys? Yes. Right. Yeah, so what I want you guys to do is once you guys have finished this, showing your work, take a picture and attach that to your Google Doc, whatever, assignment, and then submit. So for this one, okay, 75 divided by 5 would give me a total resistance of 15.
May I have your attention, please? The following students, please report to the main
All right,
office.
come on. Okay. See you guys. So once you have the total voltage, total current, if you do the division, all right, using Ohm's law, that would tell you that the total resistance would need to become to 15. Now, since there's only 2 resistors, it's very simple. If the total's 15 and one of them is 10, subtract the total minus the other resistor, or resistance values, if there's more, and the remaining would be your value here for R2. So this dude should come out to be 5. when you draw out the table and do the work, you should also see that as well. Okay. So with this, guys, again, once you have your Ohm's law triangle, you have your rules. We are going to move on. We're going to start with this one here. We're going to work on this problem here. The second one. So the top right, we're going to work on this. So a couple things. All right. Again, this symbol, this is a voltmeter. When you see this, that is telling you the voltage drop across something. So if you saw that over a resistor value, like over here, and since it goes with R2, this would be V2. It'll make sense once I show you guys the table. Okay, when you see it across a battery, that is your total voltage. That is your total voltage. So how we want to do this is, you want to set up a, we want to set up a table, our Ohm's law table for this. So we have three things. We have voltage, we have current, and we have resistance. How many resistors do we have in this one? 3. So however many resistors you have over across like this, you're going to add that many rows. So we have resistor 1, resistor 2, resistor 3, and then we have the total. So however many resistors there are, you write that many numbers down, and then afterwards, then you have T for the total. Yerp. The next thing you're going to want to do from here is you're going to want, all right, to write in all the information that you are given. So what am I given? 60. Where would that go? Where? For 1? At 2. Well, where is it going across? The battery, which is the total. So you have VT here of 60 volts. What else are we given number-wise? 14. What is that? Literally says it next to it. R2. So R2 is going to be 14 ohms. And this thing is like a weird upside down little horseshoe looking thing. All right, it's the Greek symbol omega. Do we have R1? What is that? And do we have the third? 10. So that's all we're given so far. Yeah? Okay, well, one of our rules up at the top is total resistance can be found by adding all the resistors together. So what we're going to do is find RT. Okay, and that's just going to be R1 plus R2 plus R3. So I'm going to do 6 plus 14 plus 10. And what do I get? 30 ohms. So now I take that number and I put it in the RT spot. And then here starts to come out the beauty of the table. In order to get a missing spot, you need to have 2 of the 3. We only have 1 of the 2 in the first for V1 or I1. We only have 1 of them for V2 or I2, and only 1 for V3 or I3. But we have 2, right? We have VT and RT. So then what do I do? Then, okay, I use the Ohm's law triangle. Then I use Ohm's law triangle. So I want IT. So if I want I, if I cover that up, it's V divided by R. So I'm going to do VT divided by RT because they all need to go together. All right, the total voltage, total current, total resistance all go together. V3, I3, R3 all go together. So once you have this, guys, you're right, then we plug this into Ohm's law triangle. So what do we have for our total voltage? We have 60. And what do we have for our resistance? Our total resistance, we have 30. And 60 divided by 30 is 2 amps. So we got that dude. Now I can plug him where? Under IT. So here I'm going to put it as 2 amps. All right, sweet. But Mr. Lombardo, where do we go from here? We still don't have 2 of 3 for these guys, so how do I figure those ones out? Good question. Well, answer. One of our rules. The current is the same at every single spot. So IT is equal to I1, I2, I3, however many we have. Because there's only one path that the current can take. So guess what? You don't even need to do maths for this. Once you have current anywhere, they're all the same. And guess what? Now we can find V1 and V2 and V3. And how do we do that? Well, using the triangle. What is, if I want V, what am I going to use? I times R. But remember, all the 1s go together, 2s and 3s. So V1 would equal I1 times R1. And what are my values for that? I1 was 2. And R was what? So that gives me 12 volts. V2 is I2 times R2. So we're going to have 2 times 14. And I believe that is 28. And then we have to get V3. And R3 was what? 10?
Yeah.
2 times 10 is 20. Now, one of our rules is that all the voltage drops, V1, 2, 3, however many we have, need to equal the total voltage. No more, no less. So what I always say is before you write these guys in here as your final, add them all together. So 12 plus 28, what is that? That's 40, and 40 plus 20 is... Okay, now if it comes out to be exactly what the battery is, then you're good to write those numbers in. Because there are certain problems where they may come out in decimals. So let's say they did something like this. Okay, adding these together is going to give us what? Well, these dudes here would be 60, correct?
Those dudes there would be 58.
60, and then
70.
61.1. 61.1.
What for?
If you added these together, I'm saying,
All three of those?
yep. I believe it's
No,
61.1.
I think it's like 71.
Well, 12 plus 28 plus 20 was 60. So literally just have decimals here.
Yeah, it's 61.
So 61.1. So if the value happens to come out to be more than or less than the total, we would have to figure out a different rounding, a way to round. All right, so you would need to just play around with that until it works out to fill those in. But these ones work out nice and clean. Nice and clean, so we ain't got to worry about that. And so I can now plop in my numbers here in the table. 12, 28, and 20. Bing, bang, boom. All right, easy peasy, lemon squeezy. Next one I want to do is I want to do this piece here.
Wait, where do we put it on this paper?
Where do you put all those answers on this paper? So see here, this is the one we just did.
Yeah.
This is all of our information. So what was our RT?
30,
What was our IT?
2,
I1,
2,
I2, and I3. And then what were my voltages? V1 was
28, 20.
12, 28, and 20. Cool.
And where's the first? The first one was what?
We didn't do the first one. This was the work for the first one. I'm recording this so you'll be able to see that. Okay. I want to go to the third one because the third one we haven't seen one like that. The first one is just like this. It's just one less resistor. So it's the same steps. This one is slightly different, so I do want to go over this one. So like I guess this would be technically if this was 1, if this was 2, this would be like 3. So with this guy, what do we got? All right, how many resistors do we have? 2. So I'm going to make my table. V, I, and R. I have 1, 2 resistors, that's it. So then I have my total. Okay, what information do I have given? The total voltage is 75 volts. Nope, that's a good question, but no. All right, no, we're not adding this 25 and the 75. But what else do we have? So I definitely know I have R1, which is 10 ohms. And now, Mr. Lombardo, I'm a little confused because what the hell is this 5A for? And why is this one 20? Is this a second bat? No. Good questions. When you see this circle on a wire, right, and it has a number in it, and A, that is an ammeter. That is telling us what the reading is of the current. And guess what? That current's the same everywhere. So we don't even need to do any math to find I. It's literally going to be 5. 5 amps, 5 amps, and 5 amps. Dope. Now, what is this? Remember this symbol, when it goes across a resistor or across a battery. When it goes across a battery, that tells you the total voltage because that's the same as the battery. And if you see it across a resistor, since it's over the second resistor, this would be V2. So V2 is 25 volts. Yeah. Guess what? How cake is that? That's easy. That's easy. Now there's a couple of different ways that you can complete this. Remember that the voltage drops, V1, 2, however many there are, when added together, need to equal the total. So if I already know the total, and one of these, I can just do what? Subtract. So you could do it like this. You could have done, 75 minus 25 means this would need to be 50. Or, since I have 2 of these values, to find V1, I would do I1 times R1, which would be 5 times, which gets me to be 50 either way. All right, so it could be 50 either way here. And I know that one's for a fact because this one's already set in stone and they add up perfectly to the 75. Okay, so now what do I do for these dudes? Yeah, now to find R, if I go to the triangle, if I want R, what am I doing? V divided by current. Voltage divided by current. So I'm going to do R2 is what? It would be V2 over I2. When I do that, I'm doing V2 is 25. Yep. And I is 5, which gives me 5. And what is the unit for resistance? It's ohms. So now I know what this guy is. This dude is 5, so I'm going to put it here. You can find RT doing the same steps. You can do VT divided by IT, or if you remember that the total resistance is equal to all the resistors added together, if you just add 5 and 10 together, it would give you 15.
Same thing.
Is this due like tomorrow we bring this to? Or?
So for this 4, right, you make our table. V, I, and R. There's 2 resistors, so we have 1, 2, and then we need our T. Fill in the 2 pieces of information that we're normally used to. Okay, what the hell is this thing? When you guys see in a series circuit like this, a circle that has a number inside and the letter A, that is an ammeter, which measures the ampage, or the amperes, which is our current. Series circuit. What is true about our series circuit? Yes, sir. Okay, so for a series circuit, the current is the same at every single spot. So this literally doesn't matter where we put it. It's any one of those. So let's just say here, we have 5 amps. It means I2 is 5 and I1 is 5. Now notice in number 4, they didn't give us the battery voltage. They didn't give us the total voltage, so yikes, that's not good. But now that we have the current everywhere, look what we have. We have 1, right? We're missing this guy, and this guy. So in this last one, we're missing 2 things, correct? Up top, we're missing just 1 and 1. So like that, when we're just missing one of them, use Ohm's law triangle. So if I wanted V1, that would be I1 times R1. So that would be 5 times 25 volts. V2 would equal I2 times R2. Is it? It's not 10, is it? It's 15. Yeah, it's 15. So that should be 75, right? All right, so 5. And then the second resistor value is this, which is 75 volts. So I have those 2 things here. So how can I find the total voltage? By adding up all the voltage drops. Well, I only have, all right, I have V1 and V2. So let's write that in just for it. 25 volts, 75 volts. If I add these 2 together, what do I get? Now I have the total voltage. Now you can do this last one of 2 different ways. Okay, there's some of these you can do in a different way, or like 1 or 2 different ways. Yeah, so I could have literally done this. I could have added 5 plus 15 and got 20. And then I could have done IT times RT, 5 times 20 to get 100. But over here, I did these 2 guys first, and then I just added. All right, vice versa. If I didn't add this and I said, okay, well, what's RT? If I had, all right, if I use the triangle, that would be V over I. It'd be VT over IT. This is just a second way that you could do it. 100 over 5, and that would give me 20 ohms. But what we did before was just easier by adding them. 5 and 15 give me 20. So you guys can see in some of them there are multiple ways to do these, to attack them. Okay? So we're going to leave off here for now. Make sure you bring this with you tomorrow. Everything bring back with you. Okay?
Are you doing this?
We're gonna finish this up like rather quickly in the first half tomorrow, and then we're gonna continue on with the circuit investigation.
Can you hold on to mine, because I don't want to hold it.
All right, so let's finish this off with 6. All right. Well, redo this. There we go. That makes it a little bit easier, I think. Okay, so this dude, we will call him number 5. We need our table. V, I, R. How many resistors? 1, 2, 3. So we're going to have 1, 2, 3 rows, and then our total. What are we given? We're given R1 as 5 ohms, R2 as 3 ohms, and R3 is 2 ohms. And what else are we given? We're given the voltmeter, right? The voltage drop across the battery, which is the total voltage. Okay, so this one's very similar to 1 and 2, where we have all of the resistors that we are given, so we can add them up. 5 plus 3 plus 2 is going to give us 10 ohms to get the total current. Okay, remember you need 2 of the 3 in order to use the triangle. So if you look at the triangle and you cover up I, it's going to be V over R, but remember every subscript needs to go together, so VT over RT. So 20 divided by 10. 2 amps. Once you get it in one position, it is the same everywhere. And now you have your boys. All right, you got V1, I1 times R1, V2, I2 times R2, V3, I3 times R3. 2 times 5. That is going to equal 10. That is going to be 10 volts. Then we have 2 times 3, which is going to give me 6 volts. Why did I put ohms here? Sorry for that. And 2 amps times 2 ohms. Which gives me 4 volts. Add them together to just double check. 6, 4 is 10, 10. That is 20 volts. Does that match our total? It does. So these values are good to go. Okay, so this is our number 5. And now we're going to go to number 6. So how many resistors do we have? We have 3. So we have V, we have I, we have R. We've got 1, 2, 3, and then we can't forget the T. Total. Okay, what are we given? We're given Jesus, not a lot. We got VT is the battery. The voltage drop across that is 40. We have nothing here for R1. R2, we don't have the resistor value, but what are we given? We're given the voltage drop across R2, which is good. That's important. Then for R3, we're given the fact that we have what? 10 ohms and a voltage drop of 20 volts. Okay, and that's it. That's all we're given. So let's figure everybody out. We have the only one we have 2 of 3 with or of. We can't do any adding here. Well, we know what the total voltage is. We know 2 of the 3, so there's 2 ways we could figure out V1. We could subtract total minus these guys, or once we figure out no, actually that's the only way we're going to be able to do that one currently. Ha, no pun intended. Or was it? I don't know. You could say that was shocking. Okay, I need to stop. Big time. Anyway, so let's find just V1 right this second. So V1 is going to equal the total voltage minus all the other dudes. All right, so V minus V1 minus V2. So we're going to do 40 minus, I'm sorry, that would be minus V3 because we're looking for V1. So 40 minus 20 minus 10, we're going to get 10 volts. So that is our V1. Okay. So again, the only one we have 2 pieces for is, all right, R3 piece. The voltage drop V3 and the resistor for the third resistor is 10 ohms. So to figure out the I3, the current there, all right, I would equal V over R, so V3 over R3. And you're going to do 20 over 10, and it's going to give us a current here of 2 amps. Once you find the current at one position, it is the same at all positions. So I'm going to fill this dude in. And guess what? No math here, just yerp. Put this in. And guess what? Now, very simplistically, we can do this. All right, we can find RT 2 ways. All right, you can do RT is VT over IT and get your answer. Or find R1 and R2, then you can add them together to get the RT. Either way. Let's just do this in order. R1 will be V1 over I1. 10 over 2, we're going to get 5. R2, D2, is going to equal V2 over I2. And that is going to be 10 volts over 2 again. Okay. So with this, we know this guy is here and that this guy was also the same. So we could do this just to add 5 plus 5 plus 10 is 20, or just to show it, would be 40 over 2. And so that 20 matches up with the adding of these guys. So there's the ways you guys can go about and solve for all of these. All right, and that's series circuit, guys, in a nutshell.